So one question to all is, I have one router here, router 1, and guys this router have, let's say, two interface. One is fast Ethernet 0/0 and another one is fast Ethernet 0/1 R1. Done. This is F0/0 and this is F0/1. Right, both interfaces are connected with different network. Let's suppose here my network is 192.168.1.0/24. And guys, what will be the network? That depends on our requirement, right? Means number of users. According to that you can perform subnetting, correct? So let's say in this network I need around 200 IP addresses, so I can use this subnet. This side also I need 200 IP addresses, so I can use 192.168.2.0/24. Fine. These are subnets. Now from this subnet you are going to configure one IP address on fast Ethernet 0/0 of router 1 and one IP address from this subnet on fast Ethernet 0/1 on router 1. So let's suppose IP address on this interface is 192.168.1.1/24. See guys, once I will configure this IP address on F0/0, what router will do? Tell me the first thing. First of all, it is going to check duplicacy. It will generate one Gracious ARP to check duplicate IP address. It will send, it will broadcast that Gracious ARP in this subnet. Router has per port broadcast domain. That means per port broadcast domain means this is different broadcast domain and this one is different broadcast domain. Correct, guys? So there are two broadcast domain. So router 1 is going to forward Gracious ARP from F0/0 and all 254 computer will receive that, right? If anyone is using this IP address, that PC will generate reply message, because in the Gracious ARP destination IP address is going to be same. Source IP will be also 192.168.1.1, destination IP will be also 192.168.1.1. Okay, if this IP address is unique, then router is going to find network ID. How router will find network ID? Can anyone tell me network ID of this IP address? Network ID? It will convert both IP address and subnet mask into binary, then it will perform AND operation, correct? Right? So in first octet value will be same 192 dot, second octet value is going to be same because see subnet mask all bits are on 1. In third octet also value will be 1, but in fourth octet value is going to be 0/24. So router will find this network ID. After that it is going to make one entry in their routing table that this network is directly connected. C means directly connected. On which interface? F0/0. Then guys, I am going to configure IP on F0/1. So again router is going to maintain one entry 192.168.2.0/24. This network is connected on which interface? F0/1. Correct? This is routing table of router 1. Here IP address is 192.168.2.1. So for both IP address, it has calculated the network ID and it has installed it in their routing table 192.168.2.0/24. Right? Now tell me, if router is receiving a traffic, if this router is receiving a traffic where destination IP address is 192, destination IP is 192.168.1.0, sorry 1. Let's say 10. So router 1 is going to compare this IP address with your routing table, correct? Is route available in the routing table, guys, for this IP address? It will check. It will check that is this route available in the routing table. How it is going to check? it will compare. It will compare that. See, in first octet value is 192, in second octet value is 168, in third octet value is 1, in fourth octet value is 10. So is there route available in routing table? Yes or no? If yes, then tell me this destination is matching in which network, guys? In this entry or in this entry? Yes. See, this entry means match 24 bits. Match 24 bits. So 24 bits means first octet, second octet and third octet. So in first octet value should be 192, second octet value should be 168 and third octet value should be 1. In fourth octet value can be anything. It will ignore because these are host bits, right? So it is router is going to match 24 bits, right? And 24 bits is matching in this entry, not in this entry. Why not in this entry? Because see, in this entry, in third octet value is .2, but in the traffic value is 1 in third octet. So router 1 is going to forward this traffic, this packet from 0/0. Is it clear? Is it clear? Now if destination is, let's say 2.10, then destination will match in which entry? 0/1. So it will forward from 0/1. Now if destination is 3.10, then what router will do? Discard the packet. Router is going to discard the packet, yes or no? So guys, here what I want, that router should not discard the packet. Router should not discard this packet if destination IP address is 192.168.3.10. So what you will do? You will add one route in the routing table of router, right? So now don't worry about the dynamic routing. Let's suppose we have only one routing, guys, one type of routing, that is a static routing, right? So manually I am going to add one route here in the routing table of router 1, right? Network is 192.168.3.0/24. Let's suppose this network is connected on 0/0. Now if this entry is also available in the routing table of router 1, then what router 1 will do? Will it discard or will it forward? It will forward from fast Ethernet 0/0, because again here see how many bits is matching, 24 bits is matching. But guys, if here slash value is 32, then tell me router 1 will discard it or will forward it? Discard it, because this time router is going to match all 32 bits value, right? In fourth octet value should be 0, then only it will use this route. If value is 30, then tell me it will discard it or accept it? It will discard it or forward it? Forward it. Yes. What about other? Subnet is different. Are you sure subnet is different? See, this time router 1 is going to match how many bits? 30 bits. So next network is dot 4, then dot 8. And guys, this IP address belongs to which network? This network, right? That means destination does not belongs to this network. So router 1 is going to discard it. Got it? If value is 26, then if value is 26, again you can check, no brother, that destination IP address is matching in this entry or not. See, first 24 bit is matching. In fourth octet, value should be, if 2 bit is on here, in fourth octet how many bits are? 1, 2, and rest 6 bits are 0, right? So guys, my next network will be what? Next network will be what? First network is 192.168.3.0. Second network 192.168.3.164. Second network is 64. So tell me, IP address is matching in this network? Yes. So it will forward from fast Ethernet 0/0. Is it clear? So always keep in mind, by default router maintains only directly connected network in their routing table. By default router maintain only directly connected routes in their routing table. Clear? And whenever a router will receive a packet, it will compare destination IP address with their routing table. And you know how router is going to compare destination IP address with their routing table. It will find route. If let's say there is one route like this, 192.168.3.10/32 F0/1, will router drop packet or it will forward? Definitely it will forward, because all 32 bits are matching. Correct? So router forward traffic on the basis of bits only, right? On the basis of routing table, definitely, but in the routing table, how router is going to compare destination? With the help of bits, right? So let's suppose here I want to configure a route on router for all traffic. So what I can do? 0.0.0.0, right? Means don't match any bits. If I am saying 192.168.1.1/32, that means I am saying match all 32 bits. If I am saying 24/24, means I am saying match 24 bits. And if I am saying 0, means ignore all bits. Don't match any bits. Forward all traffic towards this interface 0/1 or 0/0. Now question is, if a router, see guys, the routing table of router 1 is this one. In the routing table there are some route like this: 192.168.1.0/24 is already there. 3.0/24 F0/0 exit interface. Then I have one more route, 192.168.3.128/25 on F0/0. I have one more route, that is 192.168.3.64/26 and fast Ethernet 0/0. I have one more route here, that is, let's say, 192.168.3.96/27 and F0/0. Now tell me, destination will match in which entry, guys? Right? Or let's say for each network exit interface is different. Here exit interface is 0/0, 2, here exit interface is 0/3, here exit interface is 0/4. So do you think destination is matching in multiple network? Yes, destination is matching in this network also, correct? Because see, this entry is matching only 24 bits, right? First octet, second octet, third octet. And first octet, second octet, third octet value are matching. So destination is matching in this entry also. Is destination matching in this entry? Not matching. Here also value is, sorry, 0. Sorry, value is 0 here. Here also value is 0, and here also value is 0. Now in this entry, is destination matching? No. Tell me the network ID. First network ID is 192.168.3.0. Second network ID, huh? 3.128. 128. So last IP address of first network is 3.127. So yes, destination is matching in this entry also. You can see, yes or no. This network 0/2. So destination is 3.10, right? That means this IP address belongs to this network. First network, this network is starting from 3.0 and ending on 4.0, 3.255, correct? So destination is matching in this entry also. Is destination matching in this network? No, this is not network in the routing table, right? Here is destination matching. Second network is 64, 3.0. So last IP second network is going to be 4.0. Sorry, not 4.0, 3.64. So last IP address of this subnet is 3.63, right? So see, destination is matching over here as well in this network also, right? In this network, guys, 3.0 first IP, last IP 95. So see, destination is matching over here also. So now question is, router is going to prefer which route to forward this packet? So router is going to use that route where it will match, longest, yes, longest, you can say, network bits, longest prefix length. Prefix means network ID. So now you tell me now where this router is matching longest prefix length or network bits. Router 1 have multiple route for the destination IP address, but router 1 is going to use which one? Router 1 will use that route where it is matching maximum number of network bits. So in which entry maximum prefix length is matching, guys? On 0/0 or on 0/2, on 0/3 or on 0/4? 0/4, right? Because see, if you will convert 0/4 this into binary, so I'm going to convert only fourth octet in binary. So how many bits are on, guys? How many network bits are there? 3. Rest all are 0, right? And what is the binary of 10? Binary of 10. How many bits are matching here? 27 bits are matching over here. In this network on 0/3, how many bits are matching? 5. 26 bits are matching on 0/3, on 0/2 25 bits are matching, on 0/0 only 24 bits are matching. So for best path selection, router is going to first check what? Longest prefix length. Longest prefix length. This is first step, right? Now question is, if in the routing table there are two route available with same prefix length, let's say static and 192.168.10.0/24, and on fast Ethernet let's say 0/5, and one network is there like 192.168.10.0/25, sorry 24 on F0/6. Now see, if destination IP address is 192.168.10.1, now there are two route available in the routing table. Two networks are available in the routing table for destination with same prefix length. If prefix length is different, then definitely router can compare which one is best. Yes or no? Which one is best? But this time guys, see, prefix length is equal. Then router is going to check what? AD value. Router is going to check AD value, that is administrative distance value. Distance value. Now you will ask, what is administrative distance value? What is AD value, right? So guys, for now just keep in mind AD value is nothing but trustworthy of a route. Less AD value means more preferable network. So if a router have two network with same prefix length, then router is going to check AD value. Let's suppose here AD value is 10 and here AD value is 5. So guys, lower value is more preferable. So router 1 is going to prefer which route? On 0/5 or on 0/6? On 0/6, right? Less AD value means more preferable route. Done. So first router will check longest prefix length, then router is going to check AD value, right? Administrative distance value. Which any type of route, all types of route will have one AD value, right? It is dynamic routing or it is static routing, right? Second is AD value. And guys, let's suppose AD value is also same. AD value is also same 5 and 5. So now question is, how router is going to prefer route? AD value is same on both network 5 5. Then router is going to check metric, right? So third thing is metric. We are not going to use metric in static routing, but we'll see it in dynamic routing. Metric. Done. Any question till here? For the best path, first router is going to check longest prefix length, then router is going to check AD value, then router is going to check metric. How router select best path? Based on prefix length, administrative distance, and metric. First it is going to check prefix length, longest match. Router is going to prefer longest match, then administrative distance. Now you will see what is administrative distance for a static route, what is administrative distance of dynamic routing protocols. Whatever dynamic routing protocols we have, all protocol will have one defined AD value. We can change that AD value, but by default each protocol will have one predefined AD value, right? And then it is going to check what metric. When a router receives a packet, it first look at the destination IP address and searches its routing table for the longest prefix match. The route with most specific match, means longest subnet mask, is chosen. So hope it is clear that how router is going to select best path. Example, see, I have two route, one via router number 1, one via router number 2, this one. So if a packet is destined for 192.168.1.50, now tell me this IP address, if this is the destination IP address, then router is going to use which route? First one or second one? Second one, right? Second one. Is it clear to all how it is using second one? Right? But guys, if destination is one dot, let's say 190 or only 90, then will router forward traffic? Router have only these two dot in their routing table. Will destination match? If yes, then which route? Destination is 192.168.1.90. Is destination matching in this network? No, right? Because this network will end on 1.63, correct? So then definitely router will use this network, because this time destination is matching only on this network. It's not matching in both, correct? Then guys, administrative distance value, right? If multiple routes have same longest prefix match, the router then compare AD value of this route. The route with lowest AD value is preferred. Example, you can see AD value of this route is 110, that is AD value of OSPF, and this is AD value of RIP routing protocol. So which one is preferable route? Because if prefix length is same, definitely this one, right? So this time if destination is again 192.168.1.50, so router is going to use which route? This route, because here we have less AD value. After that it will check what metric. If prefix length and AD value both are same, then only it is going to check what metric, right? And guys, if these all parameters are same, then what router will do? Then what router will do? Load balancing. Then router will do load balancing. Router have 4 interfaces. 1, 2, yeah. Sorry bro, what? Load balancing. Load balancing means, if there is one route in the routing table, two route, S 192.168.10.0 on F0/0, AD value is slash prefix length is 24, AD value is 5, and metric is let's say 10. Again, this router have one more route, 192.168.10.0/24 on F0/1 with same AD value and same metric. In this scenario, see, router have same route on two different interface, right? So first of all, router is going to compare prefix length. So prefix length is same, then it will compare AD value. Oh, AD value is also same, then it is going to check metric. Metric is also same. So if all parameters are same, then router will perform load balancing. Then it will forward some packet from fast Ethernet 0/0 and some packet from fast Ethernet 0/1. Again, we have multiple types of load balancing algorithm, guys. Like how router can perform load balancing. Equally means forwarding 50% traffic from 0/0 or 50% traffic from 0/1. Or it can perform load balancing on the basis of address, on the basis of source IP, destination IP, source MAC, destination MAC. So there are multiple types of load balancing algorithms. We'll see that later. For now, just keep in mind one thing. If all these parameters are same, then router is going to perform load balancing. Done? Just a minute. See guys, let's say this is F0/0, F0/0, this is F0/1, this is F0/2, and this is F0/3. Here my network is 192.168.10.0/24. Here my network is 192.168.128, or let's say what can be network? Yes, 120.10.128/25. Here my network is 192.168.10.196/26, and here my network is 192.168.10. What will be next network ID if I will use /27? 224/27, right? And let's suppose this router is receiving a traffic where destination is 192.168.10.1. Then router will forward from fast Ethernet which interface, 0/0 or 0/1, 2, 3. From 0/0. If destination is 129, then 0/1. If destination is 1, let's say 200, then 0/2. If destination is 230, then from 0/3, right? So these are part of subnetting. Hope you know these all networks are different. These all networks are different. But guys, if here network ID is still same, 192.168.10.0/25. 192.168.10.0/26. Tell me, all networks are same or different? First question is, all networks are same or different? Will this network not overlap? So this is your question. You can try by yourself. Okay. Okay, if these all are, let's say, different network, then if destination is 192.168.10.1, then router 1 will forward it from which interface? 0/3, 0/3. If destination is 240, then okay, let's say destination 66. If destination is 1, then it will forward from app 0/3. If destination is 50, 65, then 0/1. Very good. 0/1, because on 0/1 see the network ID, right? And the destination is matching in that network. And guys, there we have how many prefix length? 25, right? So this time destination is matching in two network, right? On 0/0 and 0/1. If destination is 129, if destination is 129, 0/0, because this time destination is matching only on this network, right? 0/0, correct? Hope these are clear. So this is best path selection. Guys, for directly connected route, AD value is 0, and we don't have any metric for directly connected network. Okay, for directly connected network, AD value is 0. So always keep in mind that router, if router is learning same network which is directly connected from any other routing protocol, or you are configuring it with the help of a static routing, then router is going to prefer to directly connected network. Like if I will configure one route here on router number 1, let's say static and 192.168.10.0/24 on, let's say, 0/5. So router is going to prefer to which network? Which is connected on fast Ethernet 0/0. Reason? Static route have AD value 1 and directly connected network have AD value 0. Right? So here you can see we have lower administrative distance value. Let me do one thing. Let me take one router here. What happened? Router 1, router 2. And guys, I have one LAN here. Just assume you are connecting two branch office together. One is, let's say, in London and one is in India. So you need to configure routing, because by default router 1 will have information of two network, router 2 will have information of again two network, correct? And one more thing, see, whenever I will configure a subnet between router, guys, like between router 1 and router 2, I will always use 2L network, right? Between router 1 and router 2, I will always use 2L network for routing. 12.1.1.0/24, or it can be 30, right? Dot 1 on router one side and dot 2 on router 2 side. Done. So let's suppose here my subnet is 192.168.10.0/24 and here my subnet is 192.168.20.0/24. Between router 1 and router 2 my subnet is 12.1.1.0/24. Let's suppose. Let me turn on the device. Router 1, router 2. Is console visible or should I increase the console size, guys? Is it visible? Okay, let me increase. Yeah. How to increase it? Appearance कहाँ पे? Preference. कितना कर दूं? 12, 14? 14 ठीक है. ये हुआ क्यों नहीं फिर? अभी एक पे भी नहीं हुआ. व्यू में जाऊं, देन ऑप्शंस, देन अपीयरेंस. यहाँ पे नहीं है ना ऑप्शन. एडिट फंट का ऑप्शन यहाँ भी नहीं है. Okay, is it visible now? So on router number 1, interface F0/1 say no set and IP address 192.168.10.1, let's say 255.255.255.0. Done. Do so IP interface brief exclude unassign. Done. IP address on fast Ethernet 0/0. Do so IP route. So it have installed this route in their routing table. CC means directly connected network. This is the network 192.168.10.0/24. And guys, here I am not able to see AD value, but AD value for this network is 0. Done. Then interface F0/0 say no set, and here I am going to configure IP 12.1.1.1 255.255.255.0. Do so IP route 12 network. So see the routing table of router 1. One network is directly connected on 0/0 and one network is directly connected on 0/1. Done. Now guys, let me take you to R2. On R2 also, on fast Ethernet 0/0 say no cert and IP address 12.1.1.2 255.255.255.0 exit interface F0/1 say no cert and IP address 192.168.20.1 255.255.255.0. So IP route. Now can these two LAN communicate with each other? Can these two LAN communicate with each other? No. Reason? Both router have only directly connected network information. Right? So if there is one PC, and here I have one PC, let's suppose. PC1 IP address is any IP address from the subnet. Let's say IP address 192.168.10.10/24 and default gateway IP address. Checking duplicate 20.10 and gateway 192.168.20.1. Done. Ping 192.168.20.10. 20.1 is the router 2. See, I am not able to ping. What error I am getting? Destination host unreachable. So what is the meaning of this error, guys? My default gateway don't have route, right? 20.10 not able to ping. Reason? When router 1 will receive the packet. See, when PC1 is going to generate ICMP packet, source 192.168.10.10, destination 192.168.20.10. Correct? PC will forward it to router to their default gateway. Router is going to compare destination with their routing table. So router 1 will check their routing table like this. So IP route is route available for destination IP address. There are two route in the routing table, right? Two prefixes are there. Prefixes means network. Is destination matching, guys, in any network? Is destination matching in any network? No. In this entry, even first octet value is not matching. In this entry, first octet value is matching, second octet value is also matching, but third octet value is not matching, right? So what I need to do, I need to add one route here in the routing table of router 1. So what I can say, see, syntax is very simple to configure a static route. 192.168.0.0 and let's say exit interface is F0/0. Now, so IP route. Is destination matching in routing table? Is destination matching in routing table, guys, now? No. Destination is not matching because see, value in third octet is still what? 0. So can PC1 forward traffic, sorry, router 1 forward traffic to router number 2? No. Right? It will compare destination 192.168.20.1. It will compare it with routing table, but in the routing table route is still not available. Right? But I'm going to remove this route, say no to this, and I'm going to configure like this: IP route 192.168.0.0 255.255.0.0 and F0/0. Will it work? Now tell me, destination is matching? Yes, bro, destination is matching this time. See this entry now, router is going to check how many bits? Only 16 bits. In first octet value should be 192, second octet value should be 168. That's it. It will ignore third octet and fourth octet, correct? So now if you will ping PC2 from PC1, see what error you are getting. Timeout, right? Timeout error means I'm not getting reply message, right? Means route is available. Route is available on default gateway, but it is not receiving reply message. So router 1 will forward traffic to router 2, but router 2 is going to discard it. One more thing here I want to check. Guys, when PC1 will generate traffic, source IP will be IP address of PC1, destination IP will be IP address of PC2. Source MAC will be what? PC1 MAC address. Destination MAC will be what? Default gateway. Correct? Router will receive it. Router is going to compare it with their routing table. So IP route. In the routing table, route is available. Yes. On which interface? On 0/0 interface. So router is going to remove layer 2 header, right? Router is going to remove layer 2 header. Then only it can compare destination IP. Now it will check layer 3 information. So router have to remove layer 2 header. And while forwarding, it will add a new layer 2 header, right? On F0/0 interface. So what will be source MAC? Source MAC in the new layer 2 header? Router 1 MAC address, correct? Router 1 F0/0. Destination MAC? Router 2. Router 2 F0/0. Right? When router 2 will receive it, again router 2 is going to compare destination with routing table. So IP route. At layer 2 it will receive because destination MAC will match. Then it will compare destination IP. Destination IP is matching in routing table. Router 2. Yes. Yes or no? Destination IP is 20.10, right? So exit interface is fast Ethernet 0/0. Again router 2 will add new layer 2 header, right? Source will be R2F 0/1 and destination MAC will be PC2 MAC address, correct? Then it will forward to router 2. When router 2 is going to generate reply message, source IP will be 20.1 and destination IP will be 20.10 and 10.10. Destination IP 10.10. Source MAC PC2. Destination MAC default gateway. Default gateway. It will forward to router number 2. Router 2 is going to compare destination with their routing table. So IP route. Is route available? Is route available? No. Destination is 10.10. Right? Two routes are there in the routing table. See, here its destination is not matching in this. Even destination is not matching in this also. Because in third octet value is 20. But in the packet value is 10 in third octet. So router 2 will discard it. Correct? So here also I need to configure one route. IP route 192.168.10.0 255.255.255.0 exit interface F0/0. So IP route. Is destination matching this time? Yes. Correct? So router 2 is going to forward this packet from F0/0. So now if I will ping from PC1 to PC2, see, ping will work. Ping is working. Ping is working and you can check the ARP table here. What is the command? So ARP, see, in the ARP table of PC1 guys, we have MAC address of default gateway, correct? In the PC2 MAC address table, so ARP, MAC address of default gateway. And after 91 seconds, this entry is going to be expired. In the router 1 ARP table, so IP ARP. We have MAC address of 12.1, 12.2 means router 2, then MAC address of 10.1, MAC address of 10.10, and MAC address of 20.10. How router 1 have resolved the MAC address of 20.1 PC2? And see guys, one most interesting thing, the MAC address of 20.10 and the MAC address of 12.2 both are same. MAC address of 12.2 and MAC address of 20.10 both are same. Is it possible? Is it possible? No, it is not possible, right? MAC address is unique. So actually, by default, one protocol is running on router. So I'm going to disable that protocol. On router number 2, first of all, let me say interface F0/0 no IP proxy ARP, right? And on router number 1, also I'm going to disable proxy ARP, interface F0/0 no IP proxy ARP. Now clear IP ARP. Clear IP ARP. I have to put IP. One 192.168.20.10. So IP ARP. Now we don't have MAC address of 20.2. Now question is, can PC1 ping to PC2? Tell me guys, think and tell me. Is it possible? If ping was not working, then tell me the reason why ping is not working. So what is the use of proxy ARP here? See guys, issue, but here we don't have wrong subnet mask. See guys, issue is in the routing table of router 1, so IP route. What it's saying, what router 1 is saying, that one network, a static network, that is 192.168.0.0/16 is directly connected on fast Ethernet 0/0. Is it true? Is it true? No. This network is not directly connected, correct? This network is directly connected with router number 2, not with router number 1. Am I right? This network is not directly connected with router number 1. And see, if network is directly connected, then router will directly generate ARP for destination. When PC1 will ping to PC2, source IP 10.1, destination IP 20.1, source MAC PC1, destination MAC default gateway. It will forward to router. Router is going to check what? Destination MAC first. It will match, then it will check destination IP. It will compare with the routing table. So destination is matching in this network, and this network is directly connected on fast Ethernet 0/0. So router is directly going to generate ARP. It will generate one ARP request, ARP request message, where source MAC will be MAC address of R1, exit interface F0/0, and destination MAC will be OLF broadcast. Source IP will be 12.1.1.1 exit interface IP address, and target IP address will be 192.168.20.10. Right? Router 1 is going to generate this ARP request message. Now router 1 will forward this ARP request message to router 2. Can router 2 forward it to PC2? No, because This interface is in different broadcast domain. This interface is in different broadcast domain. Router 2 cannot forward this ARP request to PC number 2. Correct? So can router 1 resolve MAC address of PC 2? No, never. Yes or no? Clear? When router 1 will generate ARP request, source MAC will be the MAC address of exit interface, destination MAC will be broadcast, source IP will be exit interface IP address, destination IP address, target IP address will be destination IP address. Because router 1 is thinking that destination IP address is directly connected with me. So if destination belongs to same network, then I will directly generate ARP for destination. Right? So that's why guys, see, when PC1 is pinging to PC2, router 1 is not able to resolve, so IP ARP, not able to resolve MAC address of 10.20.10, 192.168.20.10, right? Incomplete. So this is troubleshooting. If PC1 and PC2 are not able to communicate with each other, what you are going to check? First, you are going to check routing table. You will verify that both machines are able to ping their gateway or not. So see, both machines are able to ping their gateway. Their gateway IP address is 10.1. Yes. From PC2, ping 192.168.20.1. Both machines are able to ping. Then you are going to check routing table. So IP route. So route is also available. Then you will check this routing table of R2. So IP route. Again route is available. Again route is available. Then why ping is not working? So you are going to check that the router 1 and router 2 are able to resolve MAC address or not. So you will check ARP table, so IP ARP, then you will get to know, okay, my router 1 is not able to resolve MAC address of 192.168.2.20.10. So issue is this, that this network is directly connected. It should not be directly connected. So in real time, you will never configure a static route like this. Right? So I am going to remove this static route configuration. Do so, run section route. I'm going to remove this static route configuration. Say no to this. On router number 2 also. Do so, run section route. Say no to this. Now again you can check routing table of router 1. We don't have route, so IP route. We don't have route for destination IP address, right? On router number 2 also, so IP route. We don't have route. So guys, next method to configure a static route is IP route 192.168 dot, or even say I can say 192.0.0.0, or I can say 192.168.240.0, but subnet mask is 255.0.0.0. So it is going to match only 8 bits. It is going to match only 8 bits. So how many bits router will match, that depends on submit mask only, right? That depends on, see, if I am configuring network like this on F0/0, how many bits it will match? 16 bits. Will destination match in this entry? This network ID? No, because in second octet value should be 0. So do so IP route. See the routing table, how it have installed it like this. Okay, so subnet mask is going to identify how many bits I need to match. So IP route 192.168.20.0, or I can configure network like this: 192.168.20.10, 255.255.255.255. Only one IP address will match in this entry, correct? And instead of saying exit interface here, I am going to define next hop IP address, which is 12.1.1.2. See how router is going to install network in routing table. So IP route. This time what it's saying, this network 192.168.20.10 is reachable via 12.1.1.2. So this time router is not going to generate ARP directly for destination IP address. It will generate ARP for 12.1.1.2, because this time router 1 knows that this network is not directly connected. This network is reachable via this IP address, correct? And on router number 2 also I am going to say IP route 192.168.10.10, 255.255.255.255, and next hop 12.1.1.1. Now can PC1 ping to PC2? Will ping work? Why ping is not working? Why ping is not working? Is route available? Yes, route is available via 12.2. Do so IP ARP MAC address of 12.2. So router 1 is going to forward it to router number 2. Router 2 will compare destination with their routing table. Do so IP route. Is route available? Yes. Route network is directly connected. Right? It will forward to PC2, and see on PC2 on PC2, even PC2 is not receiving request message. .20.1. Now why ping is not working? Ping should work this time. Yes or no, guys? So ARP ping 192.168.10.10 working. PC2 is able to ping PC1. Then why PC? 20.10 is the IP address, no? That's why. See, ping is working. Correct? On router number 1, I can configure one more route. IP route 192.168.20.0, 255.255.255.128. Next hop IP 12.1.1.2. I can configure one more route. Only I am going to change subnet mask. So do so IP route. So now tell me, if PC1 is pinging to PC2, destination will match in which entry? First, second, third, fourth. There are 4 routes are available. Destination, it will router 1 will use this route, correct? But if destination IP address is not 20.10, if destination IP address is 20.1, then can router 1 will forward it to router 2? Yes, right? Because see, destination is not matching in this network, right? In this entry, but it is matching over here, and over here. So router 1 will use which route? Router 1 will use which route? This one. Correct, guys? Correct? So what I am going to do, what I can do, IP 192.168.10. Or from PC1, now can I ping to router 2? Earlier this IP address was not pinging, right? 20.1. Will it work now? Will it work now, guys? Yes. It is working. Now I am able to ping this IP address. Why am I able to ping this IP address? Because this time you can see we have this network. It is matching in this entry, right? Like this, if you have multiple network in the routing table, as a network engineer, guys, you should have knowledge about network selection. That router is going to select which network, which entry from the routing table. Right? Which network? No, no, so you have to identify it only. There is no any command to check that. One thing we can do here, so we leave it for now because it will make you confused. We'll see those things later, right? For now, just you need to identify it. That router is using which route from the routing table to forward traffic. So this is routing table of router, complete routing table, but I want to see, let's say, a static. So I will say show route static. It will show me only a static route. So now tell me if destination is 192.168.20.21.1. Is there any route available? No. There is no any route available, right? If destination is 20.10, it will use which route? First number, second number, third number, fourth number? Slash 32, because here we have what? Prefix length? 32 bits are matching here, right? 32 bits are matching over here. If value is 1, then in this entry 27 bits are matching, in this entry 26 bits are matching, in this entry 25 bits are matching. So definitely it will use this one where 27 bits are matching, right? But guys, if destination is 128, then router will use which route? This 25. See, according to this network, this is different network IP address. Not broadcast, different network, na? 127 will be broadcast ID. So this not matching, correct. This IP address is not matching. So route is not available for this IP address. So while troubleshooting, you have to identify that for this IP address, route is available or not. So route is not available for this IP address. If guys destination is 66, then router 1 is going to use which route? Is this IP address matching in this network with /27? No. No. Is it matching over here in this network? No. Because network ID of next network with /26 is 20.64, right? And value over here is 66. That means this IP address belongs to different network, right? So it will use this one /25, correct? Is it clear to all? Is it clear to all? So if value in the fourth octet belongs to 1 to 30, then it will use this subnet, correct? If value is only 10, then definitely it will use this entry. If value in fourth octet is from 1 to 30, then it will use this route. And guys, if value belongs to 33 to 62, then destination is matching in this network. If value in fourth octet belongs to 65 to 126, then it is going to use this network. Is it clear? How to verify it? How to verify it? On the router number 2, I am going to run multiple networks, like let's say 10.1.1.0/24, 10.1.1.128.0/ let's say 25, 26/27. I can configure these network on router number 2, or I can connect multiple router with router number 1, right? And behind that router I can run one network, and then you can trace route to verify it. Router is forwarding traffic to which router? We can use trace route tool. Okay, so you have multiple options to verify it. You can check it. Now guys, try to understand the concept of proxy ARP. See why we come up with proxy ARP. First of all, so answer of one guys was correct. 4 wrong subnet mask. Let's suppose I have one switch here, and this switch is connected with lots of machine. Then I have one router here, R1, and this side I have one, let's say, server. This server IP address is 10.1.1.10/24, and here you have configured IP address manually. So on PC1, PC2, PC3, PC1 IP address is 10.1.1.2.1/24. Here IP address is 10.1.2.2/24, but by mistaken here you have configured wrong subnet mask on PC3, 10.1.2.3/3/8. So PC1 is going to resolve MAC address of their default gateway, right? Because according to PC1, see, the server belongs to different network, right? Because their network ID is 10.1.2.0. According to PC2 also, server belongs to different network. But guys, according to PC3, server belongs to same network, right? Because network ID of PC3 is 10.0.0.0, right? So when I will ping to server from PC number 3, so it is going to check destination belongs to same network or different network. It will use their subnet mask. It will find destination network ID 10.0.0.0, my network ID 10.0.0.0. So both belongs to same network. So PC3 will directly generate R4 server, right? And router is going to drop it. Router is going to drop the broadcast message. That means PC3 cannot access the server. So that's why we come up with this feature, that is proxy ARP. Proxy ARP. See, in a proxy, someone else is sending their MAC address instead of someone else. With the help of proxy ARP, I can tell to router number 1 that, brother, whenever you will receive a ARP request for any IP address, which belongs to different network, and if you have route for that network, then please share your own on MAC address instead of destination MAC address. So if I will enable proxy ARP on router number 1, then what will happen? When PC3 will generate ARP request, PC3 will generate ARP for 10.1.1.10 server IP address, right? It will forward to router. Router is going to check, okay, it is an ARP message, destination is 10.1.1.10. Oh, this interface and server interface belongs to a different network. Am I have route? Do I have route for this IP address? It will check routing table. Yes, I have route. That means I know where is the server. I can forward traffic to the server. So let me do one thing. Let me generate ARP reply message. And instead of MAC address of server, router will share their own interface MAC address, right? Let's say router MAC address is 0A. So router 1 is going to send MAC address of 10.1.1.10 is 0A. So PC3 will think, okay, MAC address of this IP address is 0A. So whenever PC3 is going to forward traffic to server, it will add destination MAC 0A, right? This is why we come up with ARP request. This is why we come up with, proxy ARP. And guys, here same thing is happening. If router 1 will generate ARP request message for destination device directly for 20.10, proxy ARP is by default enabled over here. Router 2 is going to check that, okay, destination is reachable from me or not. Yes, destination is reachable. So let me do one thing. Let me share my MAC address instead of MAC address of PC2. That's why, guys, in the ARP table of router 1, MAC address of 12.2 as well as 20.10 was same. Got it? 1 minute. Hello. Got it? So because of proxy ARP, we are not going to configure a static route by using exit interface. Now try to understand the issue with a static route by using next hop IP address. Guys, see, right now I have some route in the routing table, a static route in the routing table, like 192.168.20.10, 20.0, 20.0/16, and these all networks are reachable via 12.1.1.2. Is exit interface there, guys? No. Is exit interface available with routing table? No. So let's suppose if router 1 is receiving a traffic where destination is 192.168.10 20.10. So router 1 is going to check first routing table. In the routing table, it will came to know, okay, this IP address is reachable via 12.1.1.2. But router need what? Exit interface to forward traffic. So this time router 1 have to check their routing table again. What is the exit interface for 12.1.1.2? Right? So it will check their routing table again. So IP route. And this time it will find exit interface for 12 network. Okay, exit interface is fast Ethernet 0/0. So to forward traffic to 192.168.20.10, router have to check their routing table twice. And whenever router check their routing table more than once to forward a traffic, it is called recursive lookup. It is called recursive. Recursive lookup is something bad. Why? Because just try to understand, if there are 1000 route in the routing table of router 1, right? So guys, whenever router 1 is going to check their routing table, it will use their CPU. It will use their CPU. It is processing 1000 route twice. And this type of CPU utilization is called recursive lookup. So whenever we configure a static route by using next hop IP address, then we have problem of recursive lookup. Recursive lookup. Anyone can ask you what is recursive lookup. Interviewer can also ask you what is recursive lookup, or they can ask you what problem we will face while configuring a static route by using next hop IP address. So recursive lookup. What is recursive lookup? Checking routing table more than once to forward traffic. So what is the issue with a static route using exit interface? Proxy ARP, right? In that scenario, proxy ARP should be enabled, right? So one problem is proxy ARP. If proxy ARP is disabled, then you can see communication is not possible between LAN 1 and LAN 2. Proxy ARP must be enabled, and by default proxy ARP is enabled on all Cisco devices. So issue with a static route by using exit interface is proxy ARP. Issue in a static route by using next hop IP address is recursive lookup. Then what is the solution? Solution is use both, right? So we'll not configure a static route like this. Whenever we will configure a static route, we'll define both next hop IP address as well as exit interface IP address, like IP route 192.168.50.0 255.255.255.128 any subnet mask, and then exit interface F0/0, and after that next hop IP address 12.1.1.2, like this. Now you can see the entries. So IP route, here you can see we have next hop IP address as well as exit interface. So this time router don't need to check routing table twice. Got it? Is it clear to all? All means all. So you will always configure a static route by using both. If you will configure a static route by using exit interface, so IP route 10.1.1.0 255.0.0.0 F0/0. Done. Do so IP route. So guys, see, this network is directly connected. This is incorrect information, right? By using exit interface. This is the problem by using next hop IP address. So solution is this one. So we have three method actually to implement a static route. One is by using exit interface, where we have proxy ARP issue. Second is by using next hop IP address, where recursive lookup problem. And third option is by using both exit interface as well as next hop IP address. And in real time we will use both. to configure a static route. Correct? Now I am going to turn off these routers, and let me do one thing. Let me design one network here. PC switch router 1, router 2, yeah bro, this is first day of routing class. Yes, I have two router here, two more router 3 and router 4. And guys, these routers are connected like this. Here I need to add some more fast Ethernet link. Apply. Slot. While adding router in GNS3, you should at least add 4 interfaces, right? So that we can connect multiple routers together. Now this is your topology. Done. Here this is the subnet, and this side subnet is 192.168.20.0. See, instead of connecting switch and then PC, directly I can create loopback on router. So I am going to delete these all. And behind the router I can create loopback. Between router 1 and router 3 I will use 13 subnet. Between router 3 and router 2 I will use 23 subnet. Between router 2 and router 4 I will use 24 subnet. Between router 1 and router 4 I will use 14 subnet. Okay, so this is my topology, guys. Now, and let's suppose behind router 1 I have some subnet. Means router 1 is connected with few LANs like 10.1.1.0/24, 10.1.2.0/24, 10.1.3.0/24, and this side router 2 is connected with again with few network like 2.1.1.0, 2.1.2.0 and 2.1.3.0. Right? Means router 1 is connected with 3 LANs. In the same way router 2 is also connected with 3 LANs. Now let's suppose you need to configure a static route so that first two subnet users, means these subnet users and these subnet users, should communicate via router number 3, but user from this subnet and this subnet should communicate via router number 4. Can you configure a static route? If yes, then this is your task. Right? This is your task. Tomorrow you will configure it. Okay? And then you will verify the connectivity. You will verify the connectivity that all LAN users are able to communicate with each other or not. Yes, go ahead. How to create loopback interface? Loopback 1. Like this you can create loopback, and on the loopback I'm going to configure one IP, let's say 10.1.1.1 255.255.255.0, right? So loopback is virtual interface on router. And why I'm using loopback right now? To connect LAN network, right? So let's suppose loopback 1 is one switch, one switch, one LAN. In the same way we can create multiple loopback here, interface loopback 2. And guys, while configuring routers, multiple routers, for routing, simply you can run commands, all commands in notepad, and after that you can paste it on router. Like on router number 1, I need to create loopback, so I will say interface loopback 1 IP address 10.1.1.1 255.255.255.0, then interface loopback 2 IP, yes, wait bro, 192.160, sorry, 10.1.2.1 255.255.255.0, then interface loopback 3 IP address 10.1.3.1 255.255.255.0, then exit, copy and paste on router number 1 like this. This is how we are configuring devices in real time as well. Now I need to create this loopback on router number 2. So only changes here 20.1, 20.1.2.1 and 20.1.3.1. Copy and let me access router 2. I'm going to paste all commands here. Done. See. So IP interface brief exclude and assign. So all IP addresses are assigned to these interfaces. Now let's suppose I need to configure IP between router 1 and router 2. I'm going to say interface F0/0 no cert and IP address 12.13 13.1.1.1 255.255.255.0, exit, interface F1/0 no cert and IP address 14.1.1.1 255.255.255.0. I will copy it and will paste it on router number 1. Done. Then I need to configure router 3. So see, on router number 3, fast Ethernet 0/0 IP address will be 13.3. On fast Ethernet 1/0 IP will be 23.3, right? Copy and let me paste it on router number 3. Paste. Done. Then I need to configure on router 2, fast Ethernet 0/0 IP is going to be 23.1.1.2, and on fast Ethernet 1/0 IP is going to be 24.2. So 24.2. Paste. Then R4 configuration. So on R4, fast Ethernet 0/0 IP address 14.1.1.4, and on fast Ethernet 1/0 24.1.1.4. Copy, paste. Done. So I have configured IP on all routers. I can save the configuration. Say write. Save means save it in NVRAM. So if power bill goes down, still your configuration will be there. R4. Right. Now you can verify R1 show IP interface brief. So IP interface brief. See the IP configurations. Done. In the same way, now I can copy this command and let me paste this command on all router. See the IP configuration on R2. see the IP configuration on R3, see the IP configuration on R4. Now I need to configure a static route to make reachability. So as I told you, two upper subnets should be reachable via R3. So on router number 1, how many routes I need to add? IP route 20.1.1.0 subnet mask 255.255.255.255.0 and exit interface F0/0 next hop IP 13.1.1.3. Is it clear to all? Is it clear? Then guys 20.1.2.0 again for this network also exit interface and next hop IP address is going to be same. For last network 20.1.3.0 exit interface is going to be fast Ethernet 1/0 and next hop IP address will be 14.1.1.4. Copy and paste on router number 1. Done. So IP route static C, right? On router number 3, how many route I need to configure? On router number 3, on router number 3, how many route I need to configure? Router 2. 4, right? These two subnet and these two subnet. So guys, for 10.1.1.0, what will be exit interface on router number 3? 0/0. Through 0/0 this network is reachable, right? 10.1.1.0. Am I right? And next hop will be 13.1.1.1. Correct? Then 20.1.1.0 exit interface fast Ethernet 0/1. Next hop 23.1.1.2. Copy and let me paste it on R3. Can 10.1.1 ping to 20.1.1.1? Ping 20.1.1.1 source 10.1.1.1. Ping working? No. Why ping is not working? So IP route static for 20.1.1.1. Next hop is 13.1.1.3. So IP ARP. Okay. Go to router number 2. So IP route 20 network 20.1.1.1.0 on R3. 20 network not available. Huh? So run section route. So IP ARP MAC address why 20 network is not available in routing table? This network. On router number 3, why this network is not in the routing table? And guys, see the AD value. This is what? AD value, administrative distance value. For a static route, AD value is 1. And this is metric. Metric is 0. Now on router number 3, ping 23.1.1.2. next hop IP address is not reachable. So if next hop is not reachable, then router will not install that route in their routing table. So why next hop is not reachable? I can check show run interface f0/1. So this interface don't have any IP address. Interface f0/1 IP address 23.1.1.3.255.0. This IP address is overlapping with fast Ethernet 1/0. Actually, I have configured 1/0, which is not exist on router number 3. So simply I'm going to say interface f1/0 and no IP address and then shut down. Now interface f0/1, I can configure this IP and say no shut. So IP route static. Now we have entry for 20 network, right? Now can I ping from router 1's ping 20.1.1.1 source 10.1.1.1? See, still not working. How you will troubleshoot? So IP ARP 23.1.1.2 MAC address of router 2. Now sorry here, so IP ARP MAC address of router 2. Then guys, on router number 2, so IP route here 10 network should be there. Is 10 network available? Yes. Next hop IP address incorrect. Correct. 13.1.1.3. Next hop should be 23.1.1.3. Do so run section route. In the same way, you can also troubleshoot the routing issue. Say no and then IP route 10.1.1.0 255.255.255.0. Next hop 23.1.1.3. Now again let me ping and see this time ping is working. Even I can trace route 20.1.1.1 source 10.1.1 numeric. So my traffic is going to 13.1.1.3 means router number 3, then router 3 is forwarding it to 23.1.1.2 means router 2. This is the IP address of router 2, this is the IP address of router 3. So what I want, when you trace last subnet, then your path should be lower via router number 4. So this is your task to configure a static route. But guys, here again I have configured a static route by using next hop IP address. So still we have what problem? What problem I have? Yes, but here by the way you can see we have exit interface as well. I have configured I think both. Yeah. No, in GNS3 we are not going to configure switch, bro. For switching we have two software, packet tracer and EVNG. In GNS3 will perform only routing task. In GNS3 will perform only routing. Right, now let me check the question. Forwarding packet from one network to another network, that's great. Is it today the first class? Where is the question? Hello. So I need to communicate with three different hosts: 10.90.65.161, 10.90.67. Let me copy your question. I need to communicate with three different hosts: 10.90.65.161.67.136 and this. In the subnet 10.90.64.0/21, so I need to make the subnet mask of 3 hosts instead of 21. No, I didn't get your question, brother. What is your question? What is your question? I'm not getting you. This is the host. So your first IP address is .61 and last IP address is .161. See, you have, brother, one option. You can configure all three network in the routing table with /32, right? But in that scenario, you have to add 3 dot in the routing table, right? Then you have multiple options. You can perform subnetting. You can configure route like 10.0.0.0/8, 10.90.0.0/16, then 10.90 here 65, 67 and 69. Now here you have to perform subnetting. Here you have to perform subnetting and see what you can do. You can convert this value into binary to find the exact network, right? What exact network I need to install in the routing table. You will convert these all value in binary, then you will check how many bits are matching, right? Let's suppose 21 bits are matching, then subnet mask is going to be /23 21, right? Like this is, let's suppose I have one IP 192.168.10.1, one IP 192.168.10.10 and one IP 192.168.10. Let's say 50. So I want to know what is one subnet in which these all prefix will match, these all IP will match. So I have only one option. I am going to convert these all value into binary, then I will check how many bits are matching. How many bits are matching? So what will be binary of 1? What will be binary of 50? Tell me the binary of 50. Or in your scenario, value is 65, 67 and 69. So tell me the binary of 65. Just Google it, no problem. Google it. Binary of 65. Binary of 65 is 1, 6 times 0, then 1. And largest value is 69. So binary of 69 is, I think this is binary of 65. Binary of 60 is going to be this one. 1, 1, 1, 1, 0, 0. And here we have 2, 0. This is binary of 60. And binary of 69 means lowest value and largest value. Largest value is 60. Sorry. And 69, largest value is 69, so binary of 69 is going to be 1 0 0 0 1 0 1. How many bits are common? How many bits are common? Here value is 0. Here value is 0. How many bits are common? 1, 2, 3, 4, 5. Right? 6. See, 6 bits are uncommon. So 5 bits are common in third octet. All bits are common in first octet. 8 plus 8 plus 5 is going to be your CIDR value. Slash 21. Got it? Like this, let's suppose if interview is asking you to configure a static route for 3 network 10.1.1 dot 10 10.1.2 dot 10 10.1.3 dot 10 and 10.1.4 dot 10. So if someone will ask you to configure one static route for these all IP addresses, how you will find the subnet mask? First of all, you will find where is the change. So change is in third octet. So I am going to convert all value of third octet in binary. Not all value, minimum value and maximum value. So minimum value is 1, maximum value is 4. After that I will check what is the how many common bits are there, right? So binary of 1 is 2, 4, 6, 7, 8, and binary of 4 is how many bits are common? 6 bits are common, right? In first octet 8 bits are common, in second octet 8 bits are common, and in third octet 6 bits are common. So slash value is going to be what? 22. Got it? So guys, in my scenario, see, for these all network I can configure a single route on router, right? I can say like on router number 2, if I will configure this route IP route and 10.0.0.0 255.0.0.0 and exit interface is F0/0, next hop is 23.1.1.3. Tell me, all destination network is matching or not? Yes, all destination network is matching over here. Now on router number 1, I can say 20 dot IP dot 20.1.1 dot 20.0.0.0 subnet mask 255 dot 255 not 255 255.0.0.0 exit interface F0/0 and next hop IP address 13.1.1.3. On router number 2 IP dot not on router 2, sorry, on router 3 IP route 10.0.0.0 255.0.0.0 exit interface F0/0 next hop IP address 13.1.1.1. then IP route 20.1 20.0.0.0 255.0.0.0 exit interface F0/1 and next hop IP address 23.1.1.2. Now all users can communicate with each other. Ping 20.1.1.1 source 10.1.1.1. Ping is working. Ping 20.1.2.1 source 10.1.2.1. Ping is working. Ping 20.1.3.1 source 10.1.3.1. Is there something wrong? Why this ping is not working? This ping will also work. So IP route. So IP route 20.1.1.20.0.0.0 255.0.0.0. So see, route is available in the routing table. Distance means AD value 1, matrix 0. Next of IP address 13.1.1.3. Then go to router number 2 and say so IP route 20.0.0.0 This route is not in the routing table. Sorry, on R3. So IP route 20.0.0.0.255.0.0.0. Next up is correct. On router number 2, so IP route 10.0.0.0.255.0.0.0. So next hop is 23.3. So this should also work. There is some wrong static route configuration, that's why these users are not able to ping. But if I will remove the previous static route configuration, it will also work, right? Done. So guys, in this network you need to configure a static route for load balancing, let's say, or you can configure a static route for all the user from all subnet, right, via router number 3. But all the user from router number 2 to router number 1, traffic should flow through lower path. If you know the static route fundamental, like how we are configuring it, then you can manipulate the path. Because every time in a static route, we are manually defining exit interface and next hop IP address, right? Now guys, if anyone have question, please ask. From a static route, so today we seen routing. What is routing? Routing means selecting best path. Selecting best path, or you can say, in other word, you can say routing is a process of forwarding data from one network to another network. From one network to another network. Forwarding data packet from one network to another network is known as routing. In simple word, this is a good definition, I think.